Okay. Good morning, y'all. Let's see, July 7th, Thursday. I've got that one other notebook from the classroom um, that involves Python data frames that I wanted to go over today. And then after I go over that new material, I want to go back and pull up the exercise, the data wrangling exercise, and just kind of talk through it a little bit more, see if anybody has any particular questions at particular junctures in the assignment. I went over it again today and helped a couple of you, so I think the instructions are correct and what I did was right, but there's always a chance that I goofed something up. That's why I really wish if you hit a stumbling block, you'd email me your notebook and let me see exactly what is going wrong for you. That's the best way I know to help. So okay. Yep, we are recording. I wanted to go over notebook number 13, Pandas pivot tables. I don't know why, but Microsoft Teams keeps coming up kind of mysteriously for me. Okay, screen sharing. So you guys see notebook number 13. There was let me go to the modules. There's a file you need. Modules down in Python for notebook 13, bank accounts, no commas. That's one wrench I threw in that you have to fix in the pandas data wrangling exercises. There's a column with commas and it goofs up the conversion. There's probably a way to tell it that it's got commas, but the best thing is you just strip them out and then do the conversion. But for notebook number 13, you'll need this file, this CSV in your data directory if you want to follow along. And this file comes from the sample data from our Excel 2019 Bible. This particular file is used pretty heavily in their coverage of pivot tables. So I thought it was appropriate to use it here. Pretty sure went over it. I remember showing this file. Here, I'll go over it before we look at the code. Let's see. If I do that in Explorer, I will go up to Python, down into data, and look at bankaccounts.csv. And all this thing is pretty simple CSV, 700 some odd records, but it's a date, a day of the week, an initial deposit amount to create an account. These are like a log of account creations. There's a categorical variable account type, a categorical variable opened by, and that's like, new accounts or one of the tellers on the teller line opened it. Seemed like there may be one other, but we'll see that in the notebook. And then there are three branch offices of this bank, and then whether the customer was new or existing. Yeah, checking, savings, IRA, CD. Those are 4 bank account types. So this is the data that we will be reading in, and this is perfect candidate for pivoting because it repeats. there's not like a unique identifier for each transaction. Um, you would need to group and count things, and that's what's what a pivot table is great for, as far as like summarizing stuff by which branch did it, or which account type, and that's what we'll do here in this notebook. Just like we're not doing anything you can't do in Excel. Just wanted to demonstrate the capability in Python. Okay, so like I said, I got that data file in my data directory. Of course, we need pandas. So, uh, Jeanette, I'm not really sure why we're getting an odd error. You can put as much, you can import the library and do the read and all this other stuff in the same code cell. So I'm not really sure why you were getting that error.
Yeah, it was because I named everything DF. I reached out to Alyssa and she found that error, and that's why
Okay.
every time, like, why I reached out to you is like I had to copy and paste everything from like my last code
Mhm.
to like keep it continuing. And she pointed out that it was because I like called everything the same, so they kept overwriting.
Okay. So you're welcome to use the notebook I sent you this morning. I went ahead and uh, um, fixed up the first few things, so you're welcome to reuse that if you want or not. But yeah,
Okay.
I caught that. Yeah, you were reusing DF. You can, and yeah, you can have, and often do have, multiple data frames open so that you're now working with each one as if it were like a table in SQL, kind of.
Yeah,
Okay.
yeah.
Yep.
Well, thank you for doing that for me.
Well, sure. That's what I'm here for. And I didn't get. I got two questions, or two of you reached out, including the guys that are on night shift that aren't even here to ask questions in live. Two questions, two people. I'd love to help if you're hitting, if you're banging your head, like I said, bang it 3, 4 times, but don't bang it flat. If there's anything I can do to help, unless that's what you want to do, in which case, okay. But I just want to make sure everybody realizes I don't mind helping. In fact, I enjoy it. So here we go. We're going to import pandas. We're going to read in our data file and then do our big three methods that look inside the data frame: head, describe, and info. Okay, so head, of course, gives you by default your first 5 rows. There's also a dot first method, but from my reading, it's not reliable unless you have a date time as your index. So everybody uses dot head. And then, of course, dot describe gives you your descriptive statistics for any numeric field, which we only have one, the amount field. And then our dot info gives us more information about each column and how many rows. We have 712 total values. And if you check it out, only one, because Python always takes a crack at what data type it is. There's only one numeric data type here, and then the rest are object, which is really just a string. So we are going to do some data type converting, just like I've got examples of this in Notebook 12, those common wrangling chores. So we are going to make the date column a date, and our logic, our categorical variables, account type, open by branch, and type of customer as category. And then we're casting amount as int, and then doing it again to show the difference after our data conversions. So yeah, now we've got data types that take advantage more of things like pivoting and whatnot. Just seems to, if you get the data types right, there's a lot of magic that works better in a lot of these different tools, not just Python. Okay, so in the most simple example, there's two ways to pivot data. There's they're both pandas data frame methods. So this first one is I put it inside of a print statement, but just like anything else, you don't have to put it in a print statement. It prints out differently if you just call the method without using print, just like everything else we've seen, every other type of variable or function call. So I'm printing the result of calling the pivot table method. And I call the pandas library pd.pivottable, and I pass some arguments to it so that it knows what I'm trying to do, what I'm trying to pivot. So you got to tell it the data frame, what the index is, and then aggregate function. And you'll see what we're doing here. Index is like really like a row label. It's like the rows argument, or in an Excel pivot table, when you drag one of the fields over to rows, that's what index is, because that's really what an index is a row label. I think by the end of this, it'll make a little more sense. But as anything else, if you want to learn more about this, there's any number of tutorials, including my favorite site, W3 Schools. So we're going to say, give me a row, basically for each account type. And we know there's 4 account types. And we're going to aggregate on sum. Now, what you're noticing here, maybe, hopefully, is that I haven't told it what I'm summing. Sum of what? And you'll see here in a little bit, it defaults to amount because that's our only numeric field. So this first one creates or prints out. It doesn't create. I've misspoken. It prints out a pivot table that sums the amount. I didn't have to specify amount because it's the only one. And here we have our index of this resultant pivot table, which it really does return. It returns a data frame. And you know, a data frame has an index, either whether it's the default numeric 0, 1, 2, 3, 4, 5, or you name the index. All data frames have an index. So this one, I told it account type. So it is going in and finding every amount where the account type is CD and summing that and sticking it right next to it. So well, that's how that one works. Okay, so agfunc, aggregation function, is just like in the Excel pivot table in that lower right corner when you're building the pivot table. You can aggregate the sum of a column, or the count is normally the two things that you do, which is the number of times something happened versus the summation of the amounts in that. So and there are numerous ag funcs. It's all in the documentation. So we can do pretty much anything you can do in Excel. And this next one is an example of printing out a pivot table where we're indexing on branch this time. So we will have a row for each branch, which is like North County and Central, and then there's 3, I think. We'll beg your pardon. We'll see here in just a minute. And the ag func is the average, the mean. So what it's going to do is go in and look at that deposit amount and see what the average deposit amount was for a new account at each of these branches. So there you go. And that ag funk, yeah, is resulting in a floating point result because of the way the math works. So yeah, the average initial deposit in the central branch during that month of April, whatever it was, 2019, 2009. When was that? 2019. Yeah, April 2019. And this is just example data from a book. Yeah, so the average deposit amount, and you see it says amount up here. It's like I said, it's defaulting to it, but if there are more than one numeric, it will use them all, and you can specify that, which I'm doing here in a couple of code cells. You can specify if there's more than one column that can be aggregated. You can tell it which one or which ones to use. So the average deposit amount at the central branch was 8614, North County 11,000 and change, West Side 84. So I guess rich folks in the North County. There you go. So that's how we do that, and you can do group totals and subtotals if you give it more than one column in the index. It knows to go out and give me by branch, but then subdivide it by the next column that you use. So now we're going to see the central branch, but we're going to see opened by teller versus the new accounts folks, which was, it was called an MSR. Any of you work in, Christopher, you work in a bank. Member service rep is what they call it in the credit union. I don't know what they call the person behind the desk at the new accounts section versus the person behind the teller window.
CSR.
CSR. There you go. Customer service representative. Yeah. Same issue. It's kind of a level up. You start out, at least my wife did, start out as a teller, and once you figure out how all the software works and everything, they put you over where you can actually create new accounts, and some of the minor like CDs and stuff, you can start doing some investment stuff and whatnot. And then you move up from there. She was an auditor, and off you go. Anyway, enough about that. So we are passing two columns that you'll see here. It aggregates by one as like a grand total, and then a subtotal by. And the ag func we're using, again, aggregation function is the sum. And of course, it again will default to amount. So here we go. In the central branch, here's the new accounts and teller. The North County branch, here's the new accounts and teller. West Side, new accounts and teller. Now, I kind of lied, and this is sort of one of the things that I hope you guys are noticing and maybe playing with in the time I give you, if you still have time, is I would love to see a grand total by branch, but it's not in my, in my prepared presentation. And, I hate to struggle in public, but that would be, if you're all caught up, figuring out how to do one of those would be cool. And send me the code if you get to it. And I'll do the same. So yeah. And there's probably an argument. That says, grand total equals true or whatever. These things are so powerful. It's crazy. And there are 10 million different parameters you can pass to get these Python and pandas functions to do different things. So I may try and figure that out, because that would be useful. And that's something you can do in Excel. You can automatically grand total these things and then have a grand total at the bottom. Beg your pardon. Could be easier said than done, though. That's the thing about Python. It can be tough to get it to work the first time. But if it's something that you do repeatedly, once you get it working, man, it's magic. As opposed to dragging and dropping and dragging and dropping and, doing things manually with Excel. Okay, so there you go. That's passing two columns to index by. So we have a row for each of those. Now, okay, yeah, down here in my comments, amount is our only numeric field. So the previous calls to pivot table default to using the amount column. And again, yeah, that's just like the lower right corner of that pivot table. You got to tell it, you tell it what rows I want, and it gives you a row for each thing. You got to tell it what columns I want, and you drag that into columns. Well, you got to tell it what to aggregate by. And this one, this is the syntax for that. So we're going to say, and we're not doing, yeah, you see how prettier it is when you just do the method? It's kind of like pretty, like df.head versus print df.head comes out as kind of looking like text. So yeah, it's just the difference in the way the output works. So we pass it our data frame. We're going to index on branch. We're going to use the amount field in our guts of the pivot table, but this time we're going to count ag func. So it's not going to be a sum of the deposit amounts. It's going to be a count of the number of accounts. So we opened, even though it says amount, it's the count of the amount. Yeah, there's probably a way to label that column header too. But if you'll notice, the 362, 197, and 153 does in fact total up to the number of accounts that we opened in that month, 712. There's 712 total rows, one for each account creation. So this went in, yeah, this count aggregation function went in and counted them instead of summing them. And you'll see here at the bottom, you can do, or in the next one, you can do them all. You just got to pass it in as a tuple. Okay, so this next one we're going to pass in data frame. We're going to index on branch, values, amount, but now the ag func is a list of arguments, and I said tuple, but I'm trying to think. That looks more like a dictionary with the curly brackets. So anyway, I'm passing it in a list of aggregation functions. And I'm storing it. See, the pivot table method returns like a function. It returns a data frame as the return value. So I'm going to create a data frame called branch df, and I'm going to create it by calling basically all the aggregation functions at once. So that you see what is going on at each branch. And then I'm going to show the first 5 rows of that resulting one. There shouldn't even be 5 rows, but let's see here. Yeah, there's only 3 rows. So here's the resulting data frame. I stored it in branch df. So you could then, use that for resulting processing in whatever else, or write it out to an output file. And then finally here, one more, there's another way to pivot data, and the differences are so subtle that I'm not gonna try and profess the differences. They look very similar, and there's so much information out on like Stack Overflow, and I read an article on Beyond Data Science, or Toward Data Science, another great resource, Toward Data Science. But what this does is you you create a data frame using the group by method. And this, I say first, but I think I was playing around. So I'm grouping the data by branch, but some of this stuff doesn't really aggregate very well. But I want to change this real quick. Go off script here real quick. See, the actual data frame it creates isn't quite right. You have to get the grouping using a get group method, which is in the next code cell. But I wanted to change that to head and see what. What happened? Okay, so we're grouping by branch. Yeah, and it creates and I'm reusing the branch DF that I used up here, so don't get confused. This is a new use of it. So that's the resulting data frame. But when you want to see the pivot action, we grouped by branch. So now you have to go get group and pass it the name of the actual branch. And we know there are 3. So here's now we're just getting the central branch information. So it's not really pivoting the data, it's grouping the data. So you just need to decide which way you want to do that. So it's really sorting and filtering more than pivoting, I guess would be a better way to describe that. And then you get group on west side and you go, now you're only seeing west side data. But they talk about them in kind of in the same breath in the documentation, but that's the difference. The pivot table, no kidding, creates a pivot table. The group, it's like it's creating pre-made filters that you can then use to filter on a given column. For what it's worth, like I said, this is absolutely just for awareness. We're going to do a data analysis project just like we did in Excel. And if a pivot table works for you and is useful, bang, there you have it. But that will be the only real application I can think of. But I really do want to figure out, making a note for myself, I really want to figure out subtotals and grand total. In Pandas pivot table. Okay, like I said, just an awareness thing so that you realize that it is a capability that's out there and you've got some sample code. So any questions on that? Anything any of you wanted to dork around with and see what the effect was? Is that a collective? Okay, let's move on. So let me put my toys away, sell, all output clear, floppy disk, file, close and halt. Okay, so the next thing is, before I let you go to finish up the pandas data wrangling exercise today, any sticking points that you guys want to share your screen and walk through while you have me?
I guess I've got something.
Let's see what you got, Sia. Oh, sorry about that. I need to give you permission. Hang on. Advanced sharing options. Who can share? Everybody can share. Stop share. Cool. You should be able to share now.
Okay, so I guess I'm missing something here as to what the indexing does. Like if I've got to sort it anyway to get it into the order that I need it to be in to join that column, I don't understand.
Yeah, you're right. If I can talk more generically about it, when you join columns, they need to either be sorted in the, like you're actually joining a pandas series to the data frame. For the values to be correct, like right now, if you were going to join a column, what happened?
So see here, I sorted it by state, right? And then, so this is what this is. But when I try to join it down here, right? So I'm displaying this again because I'm trying to see what it's doing while I'm doing it. So this is E-ranking, right? Which is the education rankings, I guess.
Yeah.
Sorted by state, right?
Yeah.
All right. And so this is the temporary temp DF, right? And everything's still in the right order that it needs to be in. Oh, wait, it's going to screw up because 1 second. I'm going to have to clear this and run it again because it's freaking out because there's already a data frame with this stuff in it and it's trying to rewrite it if I do it like this. Sorry. Okay. Okay. So even though this is sorted, I mean, this looks like it's sorted the way that it needs to be sorted, right? But when I try to join it to states DF, it's sorted in the first way again. And I don't understand why.
You're moving so fast I can't quite keep up.
Okay.
So I want to go back to what I was saying. Generally what you want is the same index value. You want when you're joining columns or data frames, you want them to be indexed. They don't the index doesn't have to be the same name, doesn't have to be the exact same column name, but they both need to be indexed. It works best if they're both indexed on the same thing, like a 2-digit state code or an employee number or whatever the case may be. So
I mean, I get that, but what I'm saying is that if we then want to take out this one column, the overall score column, right, and make it assign it to a variable so that we can then add it on to the other states, right? Like, like the thing here says, how does it know? How are those two things connected? Are they connected at all?
Well,
like
if you index,
it sounds to me like, go ahead.
If you index them both, like your line 5 up there, temp DF equals E ranking. Temp DF equals E ranking overall score. If E ranking is indexed on 2-digit state code and you make temp DF equal to E ranking overall score, it will pull over the index of state code, and the data series will be the overall score. I'm pretty sure. I mean, I'd have to, I can't remember the syntax for anything. I'd have to run through it and look at it, but I think that's why you need to index on both of those.
But I thought I did that. I thought up here I indexed by, sorry, I'm trying to find it.
Yeah.
So I set the index there to the state name, right?
On the state, on the state STF. Yep. So it's equal to,
yeah. And then here I set the E ranking to set index state, which is this state right here, right?
So you sorted by the whole data frame by state. Okay. And then you set the index to state. And then display E ranking. Display. I'm trying to remember if I've ever even used that function. That's like print.
I'm not sure. It's what I saw when I was looking around.
I use print. Okay, so
I mean,
learn something new every day. I don't know, dude. I'm just saying I've never seen that before. So print E ranking, but it looks like it didn't work. It looks like you need an in place equals true or something, because it doesn't look like it actually set the index. When you did that display, it's still showing the numeric unnamed index. I can't keep up, dude.
Sorry. I just deleted the display, right?
Okay.
And then what I'm saying is, does this actually change the index, or does it just display things as if this was
that looks like it set the index now to state.
Okay, so if I print this, will it print out looking like this?
Do a dot head. Do a E ranking dot head. Yeah. You see, the state is not the index.
Yeah.
So I think what you're missing, and again, I can't remember syntaxes very well. I got to Google every time I do anything. I got to look at code samples and Google. But I think what you're missing, without looking it up myself, is an in place equal true for the set index method. I think that's what's happening, because what set index does, it's like temporary if you don't say that in place equal true, I think. But the way I work best is to hang on just a second. This might be a very critical call. It is. I beg your pardon, guys. This is kind of a family emergency. I'll be back in about 3 minutes.
Okay.
Seth? Is it Seth?
Yes, it's Seth.
I think he's right about the in place equals true. I'm looking at my code, and that's what I have. If you want to try that out and then do the head. I finished the assignment, so I don't mind helping you out if I can.
Okay, so is in place is what you said?
Yeah, in place, and then equal sign true. And then like, I guess just print it out with head, just to see if it worked.
Hey, I had my headphones off of my head, but it's awesome that you guys are chatting through this. This is great. So I got to make one more call. Let somebody know that help's on the way. I'll be right back.
Mm-hmm.
True is not defined. Does it need to have like?
Try it with a capital T. I have it with a capital T. I don't know if that makes a difference. Okay, yeah, it looks right now. There you go.
Okay.
So yeah, what I think, like what he said, whenever I used these functions, for some reason things didn't like save unless I put in place equals true. So it's only temporary. I think when you do in place equals true, it like overwrites your previous thing to like the thing that you're changing and saves it.
Okay. Because I think I was looking on Stack Overflow and other places, and I saw most places just put like the index and then the name in there. And I guess maybe they were just doing it temporarily. I don't know. I didn't see them reassigning things or
Yeah, I think true. If you reassigned it to like a new data frame, the new data frame will have like all the information, but then I kept getting too many data frames in my code. So then I just use in place equals true to save everything like that. Yeah.
Okay. Okay. Well then. Okay. Okay, so I think that worked now. Wait. No. That did not work. All right, so why am I getting nulls here, I guess?
I think I had the same issue. I'm trying to remember what I did to like fix it. Okay, I think the second line where it says temp df is equal to e-ranking. I think it's supposed to have double square brackets. I had used single square, and I think this is why I got that error. Try double square.
Never make it back to him, would it? See y'all later.
No, I still got nulls.
Okay.
Could you display your state's data frame before you do the join?
I'm just going to sit and listen, guys. This is great. Although, can I interrupt for just a sec? Was that in place equal true, the suspect?
Yeah.
For the reindexing? Okay, cool.
Actually, wait a second. So up here, where's that? Not there. So when I set the index here, it still needs to be in place equals true too, right? To set this state names.
Yes, that's probably why your indices are not matching up.
Yeah. And Alyssa, you're a rock star, by the way.
Thank you.
Is there a way to do this without clearing out this every time? Because
I think you can hit run all or run all above. So like go to like the cell that you want to have everything above it run, and then hit run all above, and it should just do it by itself.
Okay, yes. There
Okay, there it is. Nice. Good catch.
All right. Thank you.
You're not giving it the whole thing away for everybody, are you?
Who, me?
Yeah.
I haven't done anything else below that point.
Oh, okay.
But I guess that's what I've got, and then I'll start working on this stuff down here.
Yeah. The real key is when you're merging the data frame is for them to be indexed on the same. It doesn't have to be the same named column, but the column values need to be the same because it goes through value by value by value and matches them up. And
right.
And one other thing I wanted to, while I got Alyssa on the line here.
Hey, Bill, I'm getting a call. I'm getting a call here. I'm gonna have to stop sharing and answer this phone. Sorry.
Okay, bud. Again, y'all email me your notebooks if you're having trouble. But Alyssa, I did want to ask you, in the final CSV you submitted, everything lined up, everything was perfect. I noticed that Puerto Rico was still in there. How did that? Because Puerto Rico's not in the initial states data frame.
Good question. I'm not sure. I kind of just manipulated everything that the instruction said. Mm-hmm. So I can see what my CSV looked like to see if it had Puerto Rico in there, but well, I didn't like change the CSV or anything. So I don't know.
I'm starting to wonder if I need to do a little more research on the join method, because I was thinking when you join one to the, when you join B to A, if there are index values in B that aren't in A, like for example, the tax revenue CSV has like Puerto Rico and Washington.
Yeah,
DC,
I'm seeing it.
I was thinking that it would ignore those because there's nothing to join to in A, because there is no Puerto Rico or DC index. There's no PR or DC, that it would ignore those because there's no where to join it.
Common.
Yeah, there's no row to join it to. But I mean, your solution was like 99.99% similar to mine, so I didn't scrutinize that code this morning. But I'm curious. I'll take a look as well. But no, you're doing great. So, any other particular questions before I let you get back to work? Okay. So regardless of where you're at 12:30 today, if you would please turn in a notebook. If you don't get down to writing the CSV, of course, you won't be able to turn the CSV in. But regardless of where you're at, please turn in your notebook by 12:30, and I'll take a look. And next week, we will draw graphs with pandas and another couple of libraries. Just some simple charting so that we can then pull all this together, everything we've learned about Python, and kind of replicate that data analysis project that we did with Excel, except it'll be a little more self-contained in the form of a notebook. And I've got an example that I did that I'll go over. But yeah, guys, if you have any stumbling blocks, roadblocks, attach your notebook to an email, send it to me. I'll download it, run it on my machine, see what's going on, maybe make some comments, and try and get you started again. Okay. All right. We'll see everybody Tuesday morning. Please email me if you need me.